There's a lot of strange stuff going on in space, most of which we're unaware of. But what if we told you that the galaxy closest to the Milky Way has been devouring other galaxies for eons? In this video, we'll take a look at what the scientists have discovered in the Andromeda galaxy. Astronomers recently discovered that our intergalactic neighbor, the Andromeda galaxy, is feasting on nearby smaller galaxies. We understand how frightening this may sound, but scientists say it is a real thing. It is known as cosmic cannibalism, and it aids in the expansion of the local universe. A team led by Professor Geraint Lewis of the University of Sydney discovered signs of objects orbiting in the far outskirts of Andromeda, indicating that the galaxy had devoured two smaller galaxies in two distant epochs. What this new result does is provide a clearer picture of how our local universe has come together. It tells us that there has been this sporadic feeding of small galaxies, at least in one of the large galaxies, said lead author Lewis. The globular remains have been dubbed the Dulais structure, after the Welsh word for black stream. The Dulais structure is made up of leftovers from colossal feeding events in the recent past, as well as a dark stream illuminated by star clusters orbiting in a manner unlike any other in Andromeda. It is also evident that galaxies grow by eating smaller systems, which contradicts a more tame picture of galactic growth. This raises the question of, well, what was actually consumed? Because it doesn't appear to be just one thing. It appears to be a collection of things that are slowly being torn apart, Professor Lewis explained. Over the last few decades, we've realized that galaxies grow by eating smaller systems. So little galaxies fall in, they get eaten. It's galactic cannibalism. This discovery could help astronomers better understand our own galaxy. Further research would most likely focus on determining whether the Milky Way went through similar feeding phases to expand in the past. With the assistance of several NOIR lab facilities, an unusual ultra-faint dwarf galaxy was discovered in the outskirts of the Andromeda galaxy. The galaxy, known as Pegasus 5, was discovered as part of a systematic search for Andromeda dwarfs led by David Martinez Delgado of the Instituto de Astrofísica de Andalucía in Spain, when amateur astronomer Giuseppe Donatiello noticed a strange smudge in data in a DESI Legacy Imaging Surveys image. The image was captured with the Dark Energy camera, which was built by the US Department of Energy on the Victor M. Blanco 4-meter telescope at Cerro Tololo Inter-American Observatory. The data was processed using the NOIR Lab's Community Science and Data Centers Community Pipeline. Follow-up deeper observations using the larger 8.1-meter Gemini North telescope with the GMOS instrument revealed faint stars in Pegasus 5, confirming that it is an ultra-faint dwarf galaxy on the outskirts of the Andromeda galaxy. Hawaii's Gemini North Observatory is one half of the International Gemini Observatory. The Gemini observations reveal that the galaxy appears to be extremely deficient in heavier elements when compared to similar dwarf galaxies, implying that it is very old and may be a fossil of the universe's first galaxies. We have discovered an extremely faint galaxy whose stars formed very early in the history of the universe, said Michelle Collins, lead author of the paper announcing the discovery at the University of Surrey in the United Kingdom. This is the first time a galaxy this faint has been discovered around the Andromeda galaxy using an astronomical survey that was not designed for the task. The faintest galaxies are thought to be the remains of the very first galaxies to form, and these galactic relics contain information about the formation of the first stars. While astronomers anticipate that the universe is teeming with faint galaxies like Pegasus 5, they have yet to discover nearly as many as their theories predict. If there are truly fewer faint galaxies than predicted, astronomers' understanding of cosmology and dark matter will be severely harmed. Finding examples of these faint galaxies is thus an important but difficult endeavor. Part of the difficulty is that these faint galaxies are extremely difficult to detect, appearing as a few sparse stars hidden in large images of the sky. The problem with these extremely faint galaxies is that they have very few of the bright stars that we normally use to identify and measure their distances. Emily Charles, a PhD student at the University of Surrey, who was also involved in the study, explained. The 8.1-meter mirror on Gemini allowed us to find faint, old stars, allowing us to both measure the distance to Pegasus 5 and determine that its stellar population is extremely old. The high concentration of old stars discovered in Pegasus 5 suggests that the object is a remnant of the first galaxies. When compared to the other faint galaxies around Andromeda, Pegasus 5 appears to be unusually old and metal poor, indicating that star formation stopped very early. We hope that further investigation of Pegasus 5's chemical properties will provide clues into the universe's earliest periods of star formation, Collins concluded. This early universe fossil galaxy may help us understand how galaxies form and whether our understanding of dark matter is correct. The Gemini North Public Access Telescope offers a wide range of capabilities for community astronomers, said Martin Still, Gemini Program Officer at the National Science Foundation. In this case, Gemini assisted this international team in confirming the dwarf galaxy's presence, physically connecting it to the Andromeda galaxy, and determining the metal-deficient nature of its evolved stellar population. Future astronomical facilities are expected to shed more light on distant galaxies. Pegasus 5 witnessed a period in history of the universe known as reionization, and other objects from this period will be observed soon with NASA's James Webb Space Telescope. Astronomers hope to discover more faint galaxies in the future using the Vera C. Rubin Observatory, a program of the National Science Foundation's Noir Lab. The Rubin Observatory will conduct the Legacy Survey of Space and Time, an unprecedented decade-long survey of the optical sky. A few years ago, we discovered a sign in the objects orbiting Andromeda that the galaxy hadn't been grazing, but it had eaten large quantities in two distant epochs, said lead author Professor Geraint Lewis of the University of Sydney. What this new result does is provide a clearer picture of how our local universe has come together. It tells us that there has been this sporadic feeding of small galaxies in at least one of the large galaxies. The findings are based on the discovery of globular clusters, a type of star structure that originated outside the galaxy, in Andromeda. Professor Lewis dubbed this the Dulais structure, after the Welsh word for black stream. The Dulais structure is the remnants of a massive feeding event in the recent past, a dark stream illuminated by star clusters unlike any other in Andromeda. It demonstrates that galaxies grow by eating smaller systems, and the findings contradict a more tame picture of galactic growth. This raises the question of, well, what was actually consumed? Because it doesn't appear to be just one thing. It appears to be a collection of things that are slowly being torn apart, Professor Lewis explained. Over the last few decades, we've realized that galaxies grow by eating smaller systems, so little galaxies fall in, they get eaten, it's galactic cannibalism. Two major feeding events have been identified in Andromeda. Rough timescales indicate that the recent feast occurred within the last 5 billion years, while the older feed occurred between 8 and 10 billion years ago. The universe is 13.8 billion years old, implying that the two separate events may have occurred when matter in the universe was closer together and more densely concentrated. We know that the universe was featureless when it was born in the Big Bang, but it is now full of galaxies. Did those galaxies come fully formed, or did they evolve? According to Professor Lewis, he and other astronomers are studying Andromeda to learn more about how our own Milky Way galaxy evolved. The Earth's vantage point makes viewing our galaxy difficult because we're sitting inside it, obscuring observations. But the distance from Andromeda gives scientists a panoramic view. It is unclear how the Milky Way itself has fed, but a picture of large feasts and growth spurts is emerging in Andromeda. Given that the Milky Way is a spiral galaxy of similar size, the research could help explain how our galaxy grew to be so massive. He and his colleagues examined data on the speeds and the chemistry of the globular clusters that make up the Dulais structure, resulting in a two-dimensional view. The next step is to comprehend distances, which will enable researchers to reconstruct history in 3 dimensions. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.